4.5 Part 3. Still working on integration by substitution, just a few topics to finish up with. If you have an even or an odd function, it kind of helps to be able to break it down into their pieces. So let's talk about the ways to identify if a function is even or odd. A function is even if, when you plug negative x into the function and you simplify it, you end up with the original function. A function is odd if you plug negative x into the function and you end up with the exact opposite of the original function. So, for example, if you have x to the fourth and you plug in a negative into x to the fourth, when you raise a negative to the fourth power, you end up with the original function of x to the fourth. If you have x cubed and you plug a negative into the function, simplifying it, you get the opposite of x cubed. So this is an odd function, that's an even function. What does that look like graphically? Well, even functions will end up in the same direction. So whatever's going on in between, they'll both end up and up, or both sides pointing down. Those are even functions. An odd function will end up going in two separate directions. So if one end behavior is going down, then the right-hand end behavior is going up. Or vice versa. If it starts up, then it will end up pointing down. So those are odd functions. Thinking about what it means graphically in terms of area, let's say we've got an even function. Bad example there. Let's do this even function here. Okay, if we're trying to find the area under the curve, so this area and this area, doesn't it make sense that we could just break it here and just find the area from here to here and then multiply it times 2, because these two areas would be equal. So for an even function, you can just do the area from 0 to this number and then double it. For an odd function, let's say we've got this odd function, I'll try to draw it the best I can. This region here is going to be positive and this region here is going to be negative. But for an odd function, these two regions are actually equal area. One's just above the x-axis and one's below. So if we're finding the area from that left endpoint to this right endpoint, this area will be positive but exactly the same number as this area, which is negative. So when you add them together, you will get 0. So graphically, that's what we're talking about for even and odd functions. That's how, if you identify a function as even or odd, it will make the integrating easier. So here's the mathematical notation for all of what I just said. If f is integrable on the interval from negative a to a, so we're going equal distance from the left and the right of the x-axis, and f's an even function, then the integral from negative a to a of that even function is just the same as doing the integral from 0 to a and then doubling the answer, so times 2. If it's an odd function, then the integral from negative a to a of that odd function will be 0 because the two pieces will add up to 0. Let's do an example. Is this an even or an odd function? Well, let's see. If we plug in a negative x, we're just going to check it here. If we plug in a negative x and cube it, and then put a negative x in for this x, what does that simplify to? The exact opposite of what we started with. So this must be an odd function. Okay, let's integrate it the old way. Just add 1 to the exponent, divide by the new exponent, add 1 to this exponent, divide by this exponent, and go from negative 2 to 2. 2 to the fourth is 16, and 16 over 4 is 4. 2 to the second is 4, and 4 over 2 is 2. Minus negative 2 to the fourth is still positive 16, divided by 4 is 4. Negative 2 squared is positive 4, divided by 2 is still 2. Make sure that when you're putting those numbers in your calculator, like negative 2 to the second or negative 2 to the fourth, you're using parentheses, or else your calculator will give you the wrong number. So make sure that you're using the correct notation in your calculator. So 4 plus 2 is 6. 4 plus 2 is 6. So we have 6 minus 6. So the area is 0. We knew it was going to be 0 because we had an odd function here, and our two limits were the same number, just negative 2 to 2. Okay, that's the fundamental theorem of calculus that we used there. Now let's think about it if we didn't use the fundamental theorem of calculus. If the integral from 0 to 2 of x cubed plus x is 6, without using the fundamental theorem of calculus, what is the integral from negative 2 to 2? I mean negative 2 to 0. So thinking about what kind of function this is, we could test it again, but we know this is an odd function. So if you know it's an odd function, whatever you have between 0 and 2, that's going to be 6. So I knew I put it above the x-axis because it's positive. Then the integral on the other side, the exact same distance, must equal the opposite area. So then that must be negative 6. So obviously in this example we were able to use the fundamental theorem of calculus and get the answer. But on the AP test, they will try to get at the idea here or this idea here without giving you an actual function. So make sure that you know these ideas of the integration of an even or an odd function. Don't rely on the fact that you can integrate. All right? Be sure you know the concepts. If f of x equals cosine x and the integral from 0 to pi over 2 of cosine x is 1, then what's the integral of negative pi over 2 to pi over 2? We could integrate it, but let's think about it. Is cosine an even function? Graphically, we know cosine looks like this. Right? So is that even or odd? Do you know? Let's think about it analytically. Cosine of negative x. So does that equal negative cosine of x, which would mean that a function is odd? Or does it equal positive cosine of x, which would mean the function is even? Or neither. So let's plug in. Okay, we know cosine of pi. That's a pretty easy number. Cosine of pi is, here's your unit circle, there's pi, cosine is negative 1. What's cosine of negative pi? Negative pi goes this way, it's also negative 1. So those two are equal to each other. So cosine of negative x is the same thing as cosine of positive x. So cosine is an even function. So if we're integrating an even function from 0 to pi over 2, if that area is 1, so this area is 1, then what's the area from negative pi over 2 all the way to pi over 2? So negative pi over 2 all the way to pi over 2. Well, if it's even, we know that these two pieces must be the same. Or another way to think about it is this integral of an even function equals 2 times the integral from 0 to pi over 2. So what will that equal? 2 times 1, which is 2. And again, like I said on the AP test, they might just say f of x is an even function. And they might say from 0 to 2, f of x is negative 4. What is the integral from negative 2 to 2? So if you know it's even, you know it follows the rule that it's twice the integral. Oops, I forgot my dx here. That it's twice the integral from 0 to 2. So that would be 2 times negative 4, which would be negative 8. So make sure you know those rules. Okay, here's an example. If f is odd, and we have the integral from 0 to 3, and that equals 7, what would be the integral from negative 3 to 0? For an odd function, the integral from negative 3 to 3 is 0 if the two pieces, if it's an odd function. We break it up at 0. So if we break this one up at from 0 to 3, if that part is 7, this part has to make these two pieces add up to 0. So what must this be? It must be -7, this piece here. If the function is even, we're going from -4 to 4. If that equals 4, then what is half of it? Just the interval from 0 to 4. Half of 4, which is 2. All right. Write the integral as a sum of the integral of an odd function and the integral of an even function. Use simplification to evaluate. So they want you to break it up into two functions, one's even and one's odd. So looking at each term, pick out the ones that are an even function. So that means that if you plug in -x, you'll still get the same original part. So we're going the integral from -2 to 2 of the even parts. That's not even, obviously. 5x to the 4th is even. That's not even. If we plug in x or -x, it won't matter. It'll still be 7. So that's considered an even function. And then we want the integral of the odd parts. That's the ones that are left, x to the 5th minus 2x. Remember, for integrating, we could do the integral of each one of these if we wanted to, or we can break it up any way we want over addition and subtraction. So now let's think about the integral from -2 to 2 of 5x to the 4th plus 7. Since it's even, we could do 2 times the integral from 0 to 2 of 5x to the 4th plus 7. It just makes the math a lot easier. So 5x to the 5th over 5 plus 7x from 0 to 2, and we're going to take that times 2. 2 to the 5th is 32, and 7 times 2 is 14. And notice that the 0 we don't have to plug in, because you plug it in, I mean you do plug it in, but you don't have to write it down because it's just 0. So now our answer is 32 plus 14 is 46, and then times 2 is 92. If we had done it this way, we would have had to plug -2 into here and -2 into here and subtract them, and there would have been a whole bunch of chances for making arithmetic mistakes. So this just makes the math a little simpler. And the integral of an odd function from -2 to 2 is always going to be 0. So our final answer is 92. And if we hadn't broken it up into even and odd pieces, we would have been plugging 2 and -2 into a lot of stuff. So it makes it a little bit easier there. I don't think I have the right homework assignment on there. Oh, that was last year's. Homework for today is page 306. Whoopsie. Page 306. 47 to 105, every other odd. 107, 115, 119, 123, and 129. Remember that when a problem says C is inversely proportional to M, inversely proportional means instead of multiplying K times M, it's K divided by M. All right, just a little hint for you on one of the problems.